Assalamualaikum and hello everyone. So today, me and my friends will be present about subtopic 10.3, the sound intensity. First, introduction of the sound wave. Sound wave is produced by a vibrating source such as a guitar string, human vocals, chords, prongs of a tuning fork, or diaphragm of a loudspeaker. The second one, sound waves are mechanical and longitudinal wave which needs a medium for its propagation. Thirdly, the sound waves propagate in any medium through a series of periodic compression and rarefaction of pressure which is produced by the vibrating source. The last one is the distance between the two centers of the compression, rarefaction, represent the value of wavelength. So, what is the sound intensity? Sound intensity is defined by the energy transported per unit time across a unit area which is perpendicular to the direction of wave propagation. There are three equations in sound intensity, which is I equals to E divided by AT, or I equals to P divided by A, or I equals to P divided by 4 pi r square, where I is the intensity of sound wave, P is power of the sound wave, E is energy of the sound, A is area of a sphere of radius r through which the sound energy passes perpendicularly. And lastly, T is the time. Please note that intensity is a scalar quantity. Its SI unit is watt per meter square.
So, the dependence of sound intensity, which is I, is on the amplitude. Intensity is directly proportional to the square of the wave amplitude. Here, I is directly proportional to S squared, which is the amplitude. So, small amplitude corresponds to low energy wave, which is we get the low intensity. As you can see here, the bird make the quieter sound, produce the low amplitude, small amplitude. So the small amplitude corresponds to low energy wave, and when we calculate, we will get the low intensity. So the other one, large amplitude corresponds to high energy wave, which is we get the high intensity. So the bird make the loudest sound than the first bird and produce the large amplitude. The large amplitude is corresponds to high energy wave, and when we calculate, we will get the high intensity. So the other example is the soft sound and the louder sound. When the soft sound is made, it will produce the small amplitude and the intensity of sound will get low. While the other one, when the loudest sound produce the large amplitude, the intensity of sound will get higher than the soft sound. So the distance from 4-point source R. The intensity of a sound decreases as you get farther from the source of sound. Intensity is inversely proportional to the square of the distance from the point source. So from I equal to power over 4 pi r squared, we will get the relationship which is I directly proportional to 1 over r squared. So as you can see here, we got the sound source and the area. So in area 1, the distance from the sound source is small. So the intensity of sound is big in area 1. While in distance 3, the source of the distance 3, the area from the distance from area 3 to sound source is larger than distance 1 and distance 2. So the intensity of sound is lower in area 3. So here you can see the source and we got the R. So in R, we got the intensity which is I. When the distance increases, the R in 3R, we got the 1 over 9, the intensity of sound, because it decreases when the distance from the source, from the sound source, is increases.
Next, for the question 1 given is in figure above. 12 times 10 power of negative 5 watt of sound power passes perpendicularly through the surface label 1 and 2. This surface has areas of A1 equal to 4 meters square and A2 equal to 12 meters square. Determine the sound intensity at each surface. The solution of surface 1 is we need to use this formula of I equal to P over A, and then we need to substitute the value of P and A, which is 12 times 10 power of negative 5 over 4, and then we can get the answer is 3 times 10 power of negative 5 watt meter power of negative 2. Next, for the solution of surface 2, we use this same formula, which is I equal to P over A, and then we need to substitute the value of P and A, 12 times 10 power of negative 5 over 12, and then we can get the answer is 1 times 10 power of negative 5 watt meter power of negative 2. Next, for the question 2, the question given is a loudspeaker radiates sound wave uniformly in all directions. At a distance 3 meter, the intensity of the sound is 0.85 watt meter power of negative 2. Calculate the power of loudspeaker. We need to use this formula of intensity again, which is I equal to P over A and A equal to 4 pi r square. Next, we need to substitute the value of A here with 4 pi r square. And then we substitute the value I here, which is 0.85 equal to P over 4 pi 3 in bracket power 2. And then we can get the answer is P equal to 96.1 watt. For the B question is the sound intensity at distance 6 meter from the source. We use this formula of I equal to P over 4 pi r square, and then we substitute the value P here with 96.1 over 4 pi 6 square. And then we can get the answer of I is 0.212 Wm power of negative 2. That's all the explanation of subtopic 10.3, which is sound intensity. Thank you for watching. Bye!